Okay, morning, afternoon, or evening. Let's get that over on the other screen here. Today we're going to be looking at a couple of an extension of the chain rule, basically. Um, so if you look up here, day 9, we're going to be using the chain rule with the product and quotient rule at the same time. So we're going to look at a couple examples in the product rule and a couple examples in the quotient rule, maybe 2 and 2 or something like that. And that's basically all we're going to do because there's no new rules. It's just applying them at the same time, using the chain rule at the same time that you would do a product rule, or using the chain rule at the same time you do a quotient rule. So I'll do uh, 3 or 4 examples of that. And then in the next 2 days, in day 10 and 11, there is a sheet, and we'll talk, and I'll do a small little video on day 10 and 11 uh, that goes through all the derivative stuff that we've done since the uh, power rule up to the combos. So it takes into account the power rule, takes into account the product rule, the quotient rule, and the chain rule, and then combinations. So there's 5 different little things there. And I think there's like 15 or 20 or so questions to try. But that'll be the next 2 days. So that'll be 2 work period days. So today will be instruction, tomorrow will be work period, and the day after will be work period as well. And of course, if you have any questions, make sure you're asking them. Chat me up, send me an email, whatever you need to do if you got questions. Okay, so let's go ahead and do. This is the more complex stuff, so we're going to do a combination type stuff. So let's start off by titling this up in the first type that I'm going to do here. Let's say that we're going to do. Let's use a different color here. So let's say that I'm going to do a example of using the chain rule within the product rule. And the best way to show this is to do a few examples of. We know the product rule already, so we'll state that here. And we also know what the chain rule is as well. So, okay, so let's go ahead and just remind ourselves the product rule. Fg prime plus f prime g. Not necessarily in that order; those could be flipped, but that's how that's the product rule. Y prime equals that. So we're going to be using that. So let's do. Let's say that my example is y equals. Let's put a binomial in here, 2x minus 1 cubed. And let's do another binomial, x squared plus 4 to the power of 4. So we see that we have two f and g. We have an f and g, and we also have the idea that these are raised to a power. So we could expand the whole thing out and just get at it, but it's going to take a while to expand this out. So we could use the combination of the product rule along with the chain rule. So we could say that f is 2x minus 1 cubed, and g is x squared plus 4 to the 4th. Okay, so let's do that. Let's say that f is that first expression, 2x minus 1 cubed. Okay, now this is where the chain rule comes into play. Now we're going to do f prime using the chain rule of f. So we know that this is going to be chained. So we go, if that's our u, we could say 3 out front, and our u is 2x minus 1. Subtracting 1 power from the 3, so that would be squared. And then we have to take the derivative of what's inside the brackets. Derivative of 2x minus 1 is 2 for the 2x. Okay, now looking at that, I can simplify that a little bit to be 6 times 2x minus 1 squared. So that's the derivative of f prime. So now when we plug it in here, we're going to when we use this formula, we're going to plug that in for f and plug this in for f prime. We do the same idea for g. We take g as being the second term, okay, x squared plus 4 to the power of 4. We treat this as our u, so that'd be like u to the fourth, so that when we're doing g prime, we're going to get 4 out front, the u being x squared plus 4, and then we have to subtract 1 from that power, so 4 minus 1 is 3, and then we have to take the derivative of the inside, so that'd be derivative of this is 2x. Okay, and the derivative of that is 0, so just 2x. Okay, and we can simplify that a little bit as well by just multiplying the 4 and the 2x and to make it into a little bit neater form. So 8x times x squared plus 4 to the third power. Now we're going to apply the product rule using what we have here, and I'll just change color here for a second. We're going to be using our original equations and then these two derivatives into each of our areas of the product rule. So now we're going to apply the product rule. F times g prime. So we're going to go, so y prime equals f 2x minus 1 cubed times g prime 8x times x plus x squared plus 4. You may have noticed in my last video that I did with when we were doing the chain rule at the very last step. When I did the very last question, I made a note about it. I had the 3x plus or minus 6, and it was supposed to be 3x cubed minus 6. I just forgot the cube when I had it in the second line, but I forgot to bring it down. I did make a note of it. Hopefully you caught that. Okay, so here we go. We've got that in there for g prime. Let's make sure I typed it in right. Okay, good. And then plus f prime g. Just make sure we can see that. Plus f prime is this 6x, or 6 times, 2x minus 1 squared times g, which is the original one right here, x squared plus 4 to the power of 4. Okay, so we can leave it like this. You can make it a little neater. You can put this 8 over here. Now, some books will get you to do common factoring. And I'm going to say, most of the time, I'm going to say, you just leave it in this form, okay? But if you want to do common factoring, so I would leave here, but say maybe you want to get ready for university a little bit, they would ask you to common factor it. So this is a good answer. Leave here. This would be most of the time. Or you could common factor. So you're basically writing it in a different way. So you notice that this one has 2x minus 1 squared here and a 2x minus. So you could take a 2x minus 1 out front to the power of 2 because that's the smallest one between the two addends here. Okay, this one has a 6, this one has an 8, so you could take a 2 out front as well. Okay, so let's start with this 2x. So if you're doing common factoring, you take 2x minus 2 squared out front. And we have a common factor of 2 with the 8 and 2 with the 6. So let's put a 2 out front. So we common factored that and that. We common factored that. Now we've got 3 of them here and 4 of them here. So we can take 3 of them out. Okay, so we can take this out front. This is what they would do in a university book. So now, what's left? Okay, so if you've taken out 2 from the 8, you've got 4x left. And if you've taken out 2 of these, you've got 1 left. Okay, and if you've taken out 3 of these, you've got none of them left. Okay, so that's in there, and then we go plus. Okay, and then you've taken out a 2, so there's 3 left. You've taken out 2 of these, so there's none of these left. And you've taken out 1, 2, 3 of those, so there's 1 of those left. This is what you would end up with. And then you could work this out. And this is just the common factor way of writing it. I think this is okay. This is what we traditionally do in high school level, or I do anyway. But you could write it out like this, and then you could even go and work these out, whatever, and make this a bigger expression here. You could expand these out if you wanted and just leave those. But this would be another way to write this. These are equivalent answers. This one looks just a little bit better. So typically when you get into the university level, they'll be looking for you to common factor it. High school, I'll be just looking for you to get that step correct. Maybe you want to do some common factoring. It's up to you. Be careful though, because as soon as you make it, you go from, you're right here, and then you go to here and you do what I do and forget a squared or something, and then, oops, you made a mistake already. And then you're looking and you're wondering why you didn't get it right, even though you were good here, you just common factored wrong. So the more steps you do, the more chances for error. So this is okay, leaving it like this, and this is the common factored way. Traditionally, most of my students will do just that step. Okay, so let's do another example of the product rule here. That was only example 1. Let me just click my clock on here so I can keep track of time here. Okay, it might be a little bit longer of a day in the typical sense that no practice work today, that's tomorrow and the next day. Okay, so that one was pretty good. Let's do one with a root in it. That's another traditional one that you get for the chain rule. So, yeah, next page. Let's do it next page. Okay, so example 2 here. I'm going to do a root 1, and I'm going to do a product rule still till I title it for the quotient rule. So another product rule. Let's say that we have y equals 3x plus 1 squared. I'm not making these too complex. Square root of, what do we got? Let's make it simple, x minus 1. Okay, again, remember when you get the square root like that, you have to use this chain rule because that means square root to the power of 1/2 out here. Okay, so we're going to do the same idea that we did last time. We're going to do f g prime plus f prime g is our product rule. So we're going to say that f equals 3x plus 1 all squared. So if I were to f prime that using the chain rule, okay, we've got to chain this, bring this out front. 2 times what our variables, what's inside the brackets, 3x minus 1, or plus 1, pardon me. And we have to subtract 1 from that, so the power of 1. So we can just leave it like that. We could even expand that out, but we're not going to bother because we'll leave it in factored form. G is this x. I'm going to write it as an exponent, x minus 1 to the power of 1/2. So G prime, then if we do G prime here, we have x, 1/2 out front. Let's make that little neater there. Sorry. 1/2 out front, as we're taking that out there, x minus 1. Okay, and then we got to half minus 1, which is negative 1/2. And the derivative of what's inside the brackets. Derivative of x minus 1 is 1. That makes it pretty easy, right? So we're just multiply it by 1. Okay, so now we're going to apply the chain rule to it. Okay, so our chain rule. What am I saying? We did apply the chain rule. We're going to apply the product rule to it. F is y prime would then equal 3x plus 1 squared. Okay, that's our F. G prime is 1/2 x minus 1 to the negative 1/2. Okay, and this is just times 1, so it doesn't change anything, plus F prime 2 times 3x plus 1 times x minus 1 to the 1/2. And we're not going to even bother. We could common factor this one out, and we could common factor this one out. Okay, if we take this one out and divide it there, we can do all that kind of stuff. But, in terms of what we need to do here, let's see, did I forget to do I forgot to do the derivative here, didn't I? Okay, I forgot to chain this. We got to do the derivative of this, that's 3. So this should end up being 6 times 3x plus 1. Good. Because when we're doing that, we got to do this, but we also have to do the derivative. I forgot to chain that in there. So this should have been actually 6 right here where the 2 is. So let's take that and put a 6 there. Sorry about that, guys. To be careful when you're doing these. Okay, so that should have been when we chained it over, 2 out front, no problem. Subtract the 1 from there. But also I have to do the derivative of what's inside the brackets, just like I did here, but I forgot to do that. So we plug it in there. Okay, and I'm going to leave it in this form. We could write this as root x minus 1, and we can write this one as root x minus 1 on the bottom with the 2 if we want. So you could rewrite it like this, 3x plus 1 squared on the top, and then this stuff flops to the bottom because it's a negative root. So the 2 times root x minus 1 plus 6 times 3x plus 1 times the root of x minus 1. So if you had it in root form, some books might put it in that answer. This is good. This is also good. So that's the one thing here. Often students will ask, well, how far do you want me to go, Mr. Ehau? If you just do this first step here, just don't forget, like I did, to do that chain rule there, right? And this is fine, this first one here. But some of the answers that Mr. Friesen has or that I put in there both have been converted back into root form from the exponent. So that's how you would check that to make sure you're okay. Okay, so there's 2 examples of the product rule, okay, in terms of writing, using it in terms of doing a chain inside the product rule. Okay, let's do an example of the quotient rule with the chain next. Okay, so what happens when you have the chain rule inside a quotient rule? This is these are what I call combo derivatives. Okay. I don't know what other people call them. That's what I call them. So my example that I'm going to use for this one, looking in my little note pack here, Oh, that one's really ugly. Let's not do that one. Let's use the simpler one here. That one would take us too long. Okay, so let's say that we had, this one's pretty good. So let's say y equals x squared divided by the square root, so that's where our combo is going to come in, of 4x minus 3. Okay, so now we have to know what the quotient rule is to use. So again, I should probably, and I'll show you here, I do have a summary derivative formula sheet that I have it when we do a summary after we do implicit differentiation near the end. I do a summary day of all the derivative rules that we did, and it'll have all these rules on it. So if we do the quotient rule here, let me just look it up quick so I don't make a mistake. I think I know what it is, but I'm not going to gamble. Okay, so looked it up there. Just make sure I didn't get these mixed up because that would be bad. I was right anyway, but just in case. So let's go ahead and apply what f and g are. So if we go f is equal to x squared, f prime is easy enough. There's no chain involved in this one, just 2x. Okay, here's where our chain comes involved. If we have g being 4x minus 3 to the power of 1/2. If we write it in exponent form, g prime then equals 1/2 4x minus 3 to the power of negative 1/2, and then chain what's inside there times the derivative of that, which is 4. Okay, and then we can reduce that a little bit. 4 divided times 1/2 is 2, so we can write that as 2 times this number. Okay, now we're going to write the quotient rule out here. F prime, okay, 2x. G, 4x minus 3 to the power of 1/2, minus f, x squared, times g prime, which is 1/2, sorry, not 1/2, 2, I'm not looking all the way down here, sorry guys. Gotta look all the way down. It's 2 times 4x minus 3 to the negative 1/2. Times that whole thing. Okay, and that's all over g squared, which is going to be 4x minus 3 to the 1/2 squared. So we can simplify this a little bit because that's going to, 2 times 1/2 is just going to give us that on the bottom. Okay, so we got y prime equals 2 times 4x minus 3 to the 1/2 minus, I'm going to move this one out, this 2 out front here, so it looks a little bit better. 2x squared times, and then we can just times it by 4x minus 3 to the negative 1/2 though, which is important. Right, so I just move that 2 out there. All over 4x minus 3. Okay, so now if you wanted to you could leave it there. I would leave it there if you're not sure how to do exponent rules. But you can see that 4x minus 3 is here, and 4x minus 3 is here. So we could take the 4x minus 3 and cancel the bottom out. We could use exponent rules. So we know that 4x minus 3 to the power of 1/2. When you're dividing, you subtract the exponent. The exponent with the 4x minus 3 is 1. So this would be 1/2 minus 1. 1/2 minus 1 is negative 1/2. So you could write this as 2 times 4x minus 3, 1/2 subtract 1, for the half there and the 1 exponent there is negative 1/2. So that gets rid of this on the bottom. But if you do that over here, you got to do that over here. Minus 2x squared. Negative 1/2 minus 1 is negative 3/2 times 4x minus 3 to the power of negative 3/2. This is correct, and you might want to stop there if you're not good with exponent rules. And this is also correct. Okay, this is just another way to write it. Okay. So that's my, let me do one more example of the quotient rule. Let's do 2 each. We're about 26 minutes in, so we'll go about 35 minutes today. And remember, there's no practice for today, so it'll be tomorrow and the next day. Okay, so we'll do one more here of the quotient rule because I did 2 products. Okay, again, if you're worried about how I reduced here, you could just leave it in this form and I would be okay with that. Because I'm not going to expect you to do common factoring or that, but if you want to get practice for your university level calculus because you know you're going to do it, they'll be expecting you to simplify right to the end. Okay, so let's do one more. Let's do a simple one. Maybe you can work it out with me. Let's do y equals 2x to the 4th over 3 minus x minus 1 squared. Okay, so we know that we've got f, see, I already forgot, f prime g, right, f prime g, f g prime. F prime g minus f g prime that's what we're going to use, but we have to do f 2x to the 4th. If you want to try it on your own, you can pause it and try it and then see what I get. F prime then is 8x. Okay, so that one's easy. G equals 3x minus 1 to the squared. G prime, let's hope this time I don't forget to do the derivative inside there, like I did on the other one almost. So 3x minus 1. Okay, and we're going to do 2 minus 1 is going to give us just the 1. And the derivative inside times 3. So this is going to be 6 at 3x minus 1. Okay, so let's do our let's do our quotient rule. F prime 8x times 3x minus 1 squared. Subtract f 2x to the 4th times g prime, which is 6 times 3x minus 1, like that, all over 3x minus 1 squared again, because it's g squared. Okay, let's do some, you could leave it like that. That's the first step. But you should probably, do some simple simplification. There's a little bit there, there's a little bit there, we can multiply. So let's go 8x times 3x minus 1 squared. 6 times 2 is negative minus 12x to the fourth times 3x minus 1 all over 3x minus 1 to the fourth. All right, that's a little better, but we can see that these both have 3x minus 1s in them. Remember, you can divide out there, but if this didn't have a 3x minus 1 here, you couldn't divide this out here. Okay, it has to be across the whole thing. So if you have like something like this, AB minus C over A, you can't divide this out and say this is B minus C over A, because it's not the same. You can't just divide it. It has to be, in order to divide out an A, it has to be in both areas. So it's in both areas here, this 3x minus 1. So keep that in mind, your algebra rules, right? Okay, and this will be, we're about the 31-minute range, so I want to stop here after this one. Let's do a little more simplification here. So we can take a 3x minus 1 out of here, 3x minus 1 out of here. We could common factor it, take out a 4x out front and then bracket these ones too. But let's not do too many things at once. So this is, let's see here. Oh man, did I make a mistake here? Right? Forgot to do that. So that 8x cubed. Let's fix that up. Good thing I checked on my note there. Right? When you're doing the derivative, it's 4x squared, but I forgot to do that part. So this should have been cubed here. There we go. That's a little better. All right, so sorry about that. Look, I caught her though before the end. So you can see why you have to be careful and diligent with your powers and things. I sometimes make errors doing it. So just keeping in mind that when I did 2x to the fourth, the derivative, I said it was 8x. I forgot the cube here. Probably caught that as I was going through. I caught it here at the end. So we had to add that cube in there. Okay, so that changes it a little bit, but now we can reduce one of these from each of these. So we're going to get 8x cubed times 3x minus 1. We're going to take one away from there, take one there, and one there. And the only reason we can take one is because there's only one over here. So if I take one away, I've got one left, minus 12x to the fourth, nothing there because I take it away, all over 3x minus 1, take one away, get a 3. Okay, if you wanted to common, that's our y prime. If you wanted to common factor out 4x to the cubed out front, you could write it also in a different form as well. So that's a good form. Okay, so we could also have taken a 4x cubed out front here, and then this would have been, in brackets, 2 times 3x minus 1 minus, and then we take a 4 out of there, that's negative 3x. Right, take away that, and then 4 into that, all over this. If you want it in factored form. Again, even though I'm showing all these things, it's not a necessary requirement for, unless I say specifically. Okay, so there we have it. And if you wanted to, you could multiply this out and get 6x minus 1 minus 3. And then you could add them up together and even simplify it even a little more. So this would be, let's not do that. Let's leave it there. If you wanted to, you could, but I'm getting into university level stuff again. So this would be 6x minus 2, and minus 3, you'd have minus 3. You'd have 3x minus 2 in here if you wanted. That's also a way you could simplify it. Might as well do it since I said it. So if you wanted to expand this out, you'd get 4x cubed times, this would be 6x minus 2. So 6x minus 2 minus 3x, which would equal 4x cubed. Subtract those, 3x minus 2. And then, of course, everything is over top of this. Okay, so that would be probably the form that you would see it in the university book. In high school, we would probably go, you could easily do this one right here, but if you left it in this form, even with the 4s here, this would not be wrong. Okay, so that's 36 minutes. That's long enough. Okay, so just keep in mind that I made that error here, which we fixed about the when I had this 8x, I fixed that error, and I had another one that I fixed somewhere in here. I forgot whatever it was. So just keep in mind I caught both of those, hopefully, and hopefully I don't have any more. And tomorrow and the next day will just be a work period, and I'll have a little introductory video and it'll just be some practice derivative work from the stuff we've been doing. Okay, so that'll be tomorrow.